You use your car's alternator every time the engine is running. It powers the electrical system, keeps the battery charged, and helps everything work properly. But do you actually know what is happening inside it? We're going to walk through the entire system from start to finish. Let's start at the very beginning. Here is the first thing most people get wrong. The battery does not run your car while you are driving. The battery has one main job: to start the engine. Once the engine is running, something else takes over and powers everything, and that something is the alternator. Your headlights, your radio, your dashboard, your air conditioning, the computer running the engine itself, all of it runs on electricity that the alternator is making in real time. So where does that electricity come from? It has to come from somewhere. Your car cannot create energy out of nothing. The answer is that the alternator borrows a little bit of power from the engine and converts it into electricity. Here is the key idea for the entire video. The engine is already spinning. The alternator takes that spinning motion and turns it into electrical power. That is its whole purpose. Mechanical spinning goes in, electricity comes out. Let's follow that spinning first. On the front of your engine, there is a spinning pulley, and wrapped around it is a long rubber belt called the serpentine belt. That same belt loops around several other pulleys, and one of them is the pulley on the front of the alternator. So the moment the engine runs, the belt spins, and the belt spins the alternator. No electricity is being made yet. All we have so far is spinning being handed from the engine to the alternator through a rubber belt. Now the power is inside the alternator and ready to become electricity. This is where the real magic happens, and it comes down to one principle. Let's talk about how spinning becomes electricity. There is a rule of physics that runs this entire device. When you move a magnet past a coil of copper wire, you create electricity in that wire. You do not have to touch the wire. You do not have to plug anything in. Just moving a magnet near copper wire pushes electricity through it. Move it faster and you make more. That single principle is the heart of the alternator, and honestly, the heart of almost every power plant on Earth. So the alternator is really just a machine built to spin a magnet past copper wire over and over, very fast. Let's look at the two main parts that do this. The first part is the rotor. The rotor is the piece that spins, and it is turned into a magnet. It sits on the shaft connected to that belt-driven pulley. So when the belt spins, the rotor spins. The second part is the stator. The stator is a thick bundle of copper wire coils that stays completely still, wrapped around the outside. The spinning rotor sits inside it. So picture it, a magnet spinning rapidly inside a ring of copper wire. Every time the magnet sweeps past the copper, it generates electricity in the coils. Spin it thousands of times a minute, and you have a steady, powerful flow of electricity. But here is a detail that surprises a lot of people. The rotor is not a normal permanent magnet like the one on your fridge. It is an electromagnet, which means it only becomes magnetic when a small amount of electricity is fed into it. And this is the clever part that makes the whole thing controllable. By adjusting how much electricity goes into the rotor, the alternator can control how strong its magnet is, and therefore how much electricity it produces. A weak magnet makes a little power. A strong magnet makes a lot. This tiny control wire is how the alternator decides how hard to work, and in a second, you will see exactly what makes that decision. There is one more problem to solve first. The electricity coming out of the stator is the wrong type. It comes out as something called AC, alternating current, where the current rapidly flips back and forth in direction. But your car's battery and electronics can only use DC, direct current, which flows steadily in one direction. So the raw electricity from the alternator cannot be used yet. It has to be converted. That conversion is handled by a set of parts called the rectifier, a group of small one-way gates called diodes. A diode is simple. It only lets electricity flow in one direction and blocks it from flowing back the other way. By arranging several diodes together, the rectifier catches the back and forth AC and forces it all to flow the same direction, turning it into the smooth DC your car actually needs. Now finally, we have usable electricity. That covers how electricity gets made and cleaned up. Now let's talk about what controls all of it and where that power actually goes. The part in charge is the voltage regulator, and it is the brain of the whole operation. Your car's electrical system needs a very specific voltage, usually somewhere around 14 volts while running. Too low, and the battery slowly drains and your car dies. Too high, and you start frying sensitive electronics and boiling the battery. The voltage regulator's job is to hold that number steady no matter what. Here is how it does it, and it ties everything together. Remember that little control wire feeding the electromagnet rotor? The voltage regulator controls exactly that. It constantly watches the output voltage. If the voltage starts dropping, say you turn on your headlights, the wipers, and the heater all at once, the regulator feeds more electricity to the rotor, making the magnet stronger, which makes the alternator produce more power to keep up. When you turn those things off and demand drops, it weakens the magnet so the alternator eases off. It is making these adjustments constantly, many times per second, so you never notice a thing. That is why your headlights do not dim every time the alternator works harder. Now let's follow that finished electricity out to where it goes. A heavy main cable carries the alternator's output to two places at once. First, it goes to the battery, pushing energy back in to recharge it and replace what was used starting the car. This is why a healthy alternator keeps your battery topped up every time you drive. Second, it feeds the entire electrical system directly. Everything running in the car at that moment draws its power from here. When the alternator is making enough, it runs the whole car and charges the battery at the same time, and the battery just sits there full, ready for the next start. Now let's talk about what this means for you, because an alternator gives you warning signs before it fails. The most obvious one is the battery warning light on your dashboard. Most people think that light means the battery is bad, but very often it means the alternator has stopped charging. Other signs are dimming or flickering headlights, especially at idle, electronics acting strangely, or a whining or grinding noise from the front of the engine. And here is a useful thing to know. If your alternator dies completely while you are driving, the car will keep running for a little while on just the battery. But once that battery drains, the whole car shuts off. That is your window to get somewhere safe. There is also a simple habit that protects the whole system, that serpentine belt we started with. If the belt is worn, cracked, or loose, the alternator cannot spin properly and cannot charge, no matter how healthy it is inside. A belt is cheap. Getting stranded is not. Have it checked when you get your oil changed and replace it on the schedule in your owner's manual. It is one of the easiest ways to avoid a breakdown. That is a complete car alternator. From the spinning engine belt, through the magnet and copper coils, into clean regulated power, and out to your battery and every electronic in the car, working the entire time your engine is running. If this helped you understand how your car's alternator actually works, go ahead and subscribe for more car breakdowns. Next, we can break down how the battery and starter work together to crank the engine, how the ignition system fires the spark plugs, or how your car's entire electrical system is wired from front to back. The more you understand what is happening under the hood, the better decisions you can make as a car owner. Thanks for watching, and we will see you in the next one.